say you've got a circle of radius 2. So let's draw our circle here. And inside this circle, say that you inscribe a rectangle, which means pick any x value between 0 and 2. And how can you draw that rectangle? Well, pick your x value, then go up. And here's the point xy. Now go over to the point negative xy. Keep on going down, negative x, negative y. So on and so forth to fill out the square. And this circle has an equation of x squared plus y squared equals radius squared. It's 2 squared equals 4. And so that tells us that y equals the square root of 4 minus x squared. Inside that circle, we've inscribed our rectangle. So the question is, which x value should I pick to give me the rectangle with the most area? So this is an optimization problem because I need to find a formula for the area of the rectangle. I'm going to need to find how big can it possibly get. So first of all, what's that formula for the rectangle? That's just going to be base times height. So how can we find that? Well, our height, that's just going to be, well, here's our y value, and then double it to get the height of one side. So area, well, it's going to be 2 times y for the height. Then what about the base? That's going to be 2 times x. So here's the length of the x value, and there it is again. So that's going to be 4 times x times y. And I can rewrite this in terms of x just by saying 4 times x. And now y is the square root of 4 minus x squared. So there's the function that I need to optimize. And so a maximum or a minimum of this function can only occur at the endpoints or a critical point. If you look at the endpoints, well, you can plug in x equals 0. You'll get area equals 0. It's like a degenerate rectangle, vertical line. Plug in x equals 2, you're going to get a degenerate horizontal line looking at 2, and that formula is just going to give you 4 minus 4 is 0. So definitely the maximum of this function, if it exists, has to occur at a critical point. It's going to be a place where the derivative is equal to 0. So let's check that out. Let's find the derivative of the area function. So I'm going to use the product rule to do this. This is the product of 4x and square root of 4 minus x squared. So first derivative of 4x is just equal to 4, then times the second factor, square root of 4 minus x squared. There we go, and I add to this 4x times the derivative of square root of 4 minus x squared. So think of this as 4 minus x squared to the 1/2. Then first using the power rule, bring down the 1/2, and then I'm going to be left with 4 minus x squared to the negative 1/2. That's the same thing as putting the square root in the denominator. And now the chain rule tells me take the derivative of 4 minus x squared. The derivative of 4 minus x squared is just negative 2x. There we go. And this I want to set equal to 0 because we are a critical point when you found an x value to make your derivative equal to 0. And so I just need to set about solving this equation. So how can I do that? Well, first of all, I can divide both sides by 4 to get rid of both these 4's here, and I'm going to be left with negative 2 times x squared divided by the square root of 4 minus x squared, and I've got a 2 here and a 2 there. Those will cancel each other. I'm going to bring this to the other side. Finally, what I'm going to write down is square root of 4 minus x squared, and that's going to be equal to, well, this brought over to the other side. So what do I get? I'm going to have x squared. Remember the 4's, I divided by 4 to cancel them, and the 2's cancel each other. So I'm just going to be left with x squared over square root of 4 minus x squared. So now this is the equation that I need to solve. And what I want to do next is just multiply both sides by the square root of 4 minus x squared to give me 4 minus x squared. On the left-hand side, multiply this by the square root of 4 minus x squared. They cancel, just giving me x squared. So now I'm really getting somewhere. Just add x squared to both sides to give me 4 equals 2. X squared, that's great. So divide both sides by 2 to give me x squared equals 2. And finally, at the end of it all, I'm just going to have x will be plus or minus the square root of 2. Of course, the range of x was 0 to 2, so that lets us discount the negative and gives us a final answer of x has to be the square root of 2. And so finally, that's our answer. So if you look over here, square root of 2 is like roughly 1.41, so it's almost where I drew it, and that would give you the circle with the maximum area. Strictly speaking, you should check that this is actually a maximum, not a minimum. There's different ways to do that. You could check with either the first or the second derivative test. With the second derivative test, you could just take the derivative of this expression and show that it's positive. When you plug in x equals square root of 2, you might have better luck with the first derivative test. You can notice that when x is bigger than the square root of 2, this whole expression is going to be positive. When x is less than the square root of 2, this expression is going to be negative. So this function is switching from increasing to decreasing, giving you a maximum